My name is Yusudo from Honda Research Institute, Japan. I'll be presenting our research entitled Time-synchronous one-fast beam search for parallel online and offline transducers with dynamic block training. Yeah, firstly, end-to-end automatic speech recognition is a promising approach, and it can be classified into online models and offline models. In some applications, online ASR model is essential. But these online and offline model has pros and cons respectively. The online ASR models has fast response, but the performance is relatively poor compared with the offline ASR model. But the offline ASR model has to wait for the completion of the utterance, so it will lead a large latency. So we attempt to integrate online-offline models to take better advantage of both modes. Several attempts have been made to integrate both online and offline modes. The first approach is two-pass rescoring, consists of online transducer decoder and offline attention decoder, sharing one encoder. In this method, the secondary decoder rescores the first complete hypothesis, but it cannot correct the first hypothesis unless it includes the correct hypothesis. The second approach is cascaded encoder, which consists of a causal encoder and a full context encoder, which are connected each other in a cascaded manner. The hidden state vectors are refined by using a full context encoder, but in this paper, the authors reported that they observed significant improvements for the offline mode, but marginal gains for the online mode. So we try to improve the both online and offline modes. This page shows the overview of the proposed method, consists of a blockwise encoder and the online transducer decoder, as shown in green for the online mode, and the full context encoder and the full context offline transducer decoder for the offline mode, as shown in blue. To exploit the better advantage of both blockwise encoder and the full context encoder, the hidden state vectors generated by the blockwise and the full context encoder are concatenated and fed into the offline transducer decoder. This model is trained with multitask learning using this equation, using a weighted sum of the online loss and the offline loss with the training weight lambda. Additionally, we also introduce a block size, dynamic block size training. During training, block size is randomly selected from B min to B max for each batch, which is expected to improve the robustness of the offline decoder because it increases the variability of the hidden state vectors. And it also allows end users to change the block size flexibly during inference. Furthermore, we propose the time-synchronous beam search to further improve the offline mode during inference. Let me explain the detail of the time-synchronous beam search. Firstly, the offline transducer decoder is used as a primary decoder, and it outputs initial hypothesis used as in the conventional transducer decoder, and we obtain the probability and the score alpha. Then the online decoder rescored the first hypothesis for each time frame. This figure shows the RNNT lattice. Blue dots shows the current hypothesis, and the black dots shows the previous hypothesis. Since RNN transducer decoder may emit multiple tokens, all possible paths must be added, as shown in the figure. And then we can obtain the online score alpha. And finally, by using a weighted sum of the decoding score, the score for online score and offline score with the decoding weight mu, we obtain the alpha joint, and based on the joint score, top K hypotheses are retained to the next time frame. Yeah, to validate the proposed method, we conducted several experiments using block-wise conformer transducer for the online mode and the full context conformer and transducer for the offline mode. During training, the block size was randomly selected from block size of 5 to 50, which corresponds to 200 milliseconds and 2000 milliseconds. The training was 0.5 and the decoding weight for the one-pass beam search was 0.3. We used the CSJ Japanese dataset and the LibriSpeech 960 hours dataset. And we calculated the character error rate and word error rate for the performance evaluation. And we also calculated the emission delay for the responsiveness evaluation of the online mode. And we also compared the proposed method with two baselines using the same number of parameters. The first baseline is separate model, consists of a separate online transducer and a separate offline transducers, which are trained separately. And the second baseline is cascaded encoder, which I explained in the introduction. This page shows the main results on CSJ dataset. Firstly, parallel encoder structure improved the online mode as shown in blue, but in this experiment, we did not observe performance improvement for the offline mode as shown in red arrow. But dynamic block training significantly improved the offline mode as shown in blue, and also the proposed time-synchronous one-pass beam search further improved the offline mode as shown in this blue arrow. In summary, the proposed method improved both online and offline modes, and it also outperformed the separate model and the cascaded encoders for both online mode and offline mode. Then we analyzed the effect of the dynamic block training for online mode. This figure shows the relationship between block size and the character error rate, and the blue line shows the results of proposed method with dynamic block training, and the red and the green lines show the separate and the proposed method without dynamic block training. Trained with a predetermined fixed size, block size of 20. As shown in the green and the red line, the performance of the baselines were significantly deteriorated other than the block size of 20, whereas the proposed method significantly improved the performance for all block sizes. The right hand table shows the emission delay for different block sizes of the separate model and the proposed method with dynamic block training. As shown in this table, the proposed method significantly outperformed the separate model in terms of CER while maintaining the comparable emission delay. That means this method provides the end users to allow the end users to change the block size flexibly during inference with a reasonable trade-off curve. And we also validate the effect of the dynamic block training for offline modes. This figure shows the relationship between block size and CER again. And the blue line shows the proposed method with DB training, and the green and the red line show separate and the proposed method without the dynamic block training. Yeah, as shown in this figure, obviously the proposed method with dynamic block training also significantly improved the offline mode. Yeah, this figure shows the effect of the one-pass beam search. The horizontal axis shows the decoding weight for the one-pass beam search, and the red and blue lines show the results of without one-pass beam search and with one-pass beam search. Yeah, as shown in this table, the proposed one-pass beam search further improved the offline mode. Yeah, and we also compare the proposed method on LibriSpeech 960 hours dataset. Yeah, as well as the CSJ dataset, the proposed method outperformed the separate model and the cascaded encoder for both online and offline mode, as shown in this table. And I would like to show you the typical example of the firstly separate models for online and offline modes. The incorrect recognition results are highlighted in red. So basically, offline model has the better performance than online model, but depending on each utterance, not always offline model outperform the online model. Sometimes offline model underperform the online model, as shown in the bolded phase. In contrast, the second example shows the results of the proposed method of online and offline model plus one-pass beam search. As shown in the blue, the proposed method benefits from the both online and offline modes, allowing to effectively correct the error occurred in the first hypothesis. Yeah, let me conclude the presentation. This paper proposed a parallel online-offline transducer that integrates blockwise and full context encoders using the dynamic block training and one-pass beam search. We found that the parallel encoder structure of the online and offline model improved the online mode first. Secondly, the dynamic block training significantly improved the offline mode while allowing for flexible block size selection for the online mode. Thirdly, the proposed one-pass beam search using the online and offline transducer decoders further improved the offline mode. Yeah, thank you for your attention.